Hello and welcome to Technical Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition book. We're going to be doing problem 2.12, that's 212. All right, let's go ahead and read the problem. A right circular cone of base radius r, height h, and known density rho s floats base down in a liquid of unknown density rho f. A height h of the cone is above the liquid surface. Derive a formula for rho f in terms of rho s, r, and h, little h over big H. Simplifying it algebraically to the greatest possible extent. Recall Archimedes' principle stated in the preceding problem and note that the volume of a cone equals the area of the base times the height divided by 3. Okay. So what we want to do is look at our cone. Let's draw out the problem first. Okay. This is our angle theta. Our cone has a certain height. If we do a top-down view, we got a circle, and that has a radius of big R on the base. Our cone is floating in the water, or unknown liquid. So we've got this cone floating here. It's got a height h above the water, and the liquid has a fluid density of rho f. Okay. We need to calculate rho f. So rho f equals the mass of the fluid over the volume of the fluid. And we don't know either of those values, but we can calculate what they are probably. All right, so the mass of the fluid, we'll start there, is equal to the mass of the cone, like we described in the previous problem. I'll add a link in the top right. You can click on that to view the previous problem. Okay, so the mass of the cone equals the density of the cone times the volume of the cone, which is equal to the density of the cone, which they give to us in the problem statement, times the area of the base, pi r squared, times the height divided by 3. Okay? Then let's get the volume of the cone, or the volume of the density displaced. That equals the volume of the cone, that's the full volume of the cone, we'll highlight that in yellow. The full volume of the cone, but then we need to subtract the part that's not in the water, or that's not in the fluid. So we need to subtract out this blue portion above. So let's subtract that out. We'll call that the volume of A. Okay. We already know what VC is. We just wrote that down. So that's the area of the base times the height divided by 3. And then we have the area of the base of the smaller cone that's above the fluid. That's a little r times, that's squared. Okay. Then we need to solve for what little r is, because we don't know what that is. All right, so one way to do this is to lay the cone on its side and examine the ratio between the height. So let's draw a sideways image of the cone here, like this. Okay. And then we've got a radius here, that's r. And then we have a height here, that's big H. It goes from here to here. And then we've got, we'll draw a line through here. And this is still theta. but we're going to cut theta in half, and we've got a triangle here. That's a right triangle. Okay, so this means that the tangent of half the angle theta is equal to the opposite, r, over the adjacent, big H. Okay. Now, we also have a smaller cone section, so if we slice this cone in half, right along there, we have another little r, that's little r, and then we have from little h from here to here. And we also have the tangent of theta over 2 is also equal to little r over little h. Okay, so then we have this ratio where r over h equals big R over big H. So that means little r is equal to big R over h times little h. Okay, so now we have an expression for little r that we can use in our volume expression. So the volume of the fluid is equal to pi over 3 times big R squared h, big H, minus big R squared h squared over big H squared times little h. And we just substituted little r into there that we just calculated. Okay, so now we're looking for the density of the fluid. So now we can substitute in our expression for the volume of the fluid and the mass of the fluid. These two expressions, this expression and this expression. Okay, so let's substitute those in. It's the mass over the volume, so this equals rho s pi r squared big H over 3. And we have 3 over pi r squared h minus h3 r squared over h squared. Okay, now we can simplify this expression quite a bit. We can pull the pi 3 cancels each other. We can pull an r squared out of this expression from both of those terms, and we can cancel out the r squareds. Then we can also pull an h out of both of these terms here. And so we'll pull one h out of each of those. And we'll cancel the h, so then that will become a 3. And so then we are just left with rho s over 1 minus 8 little h to the third power over big H to the third power. And that is your final answer. Thanks for watching the video. I hope this was helpful. If you noticed any errors that I made, let me know in the comments and I will make a correction or add something to the video description. Thanks.